IoT Internet of Thing Unit 5 for RGPV Exam 2023 notes are in comment section. Unit 5. IoT Platforms. 1. An IoT platform is a software suite that provides a range of services and tools for building, deploying, and managing IoT devices and applications. 2. IoT platforms typically include features such as device management, data analytics, and connectivity management. 3. IoT platforms can be classified into 3 categories: cloud-based, edge-based, and hybrid. 4. Cloud-based platforms are hosted in the cloud and provide centralized management of IoT devices and data. 5. Edge-based platforms are deployed on devices themselves and provide local processing and analysis of data. 6. Hybrid platforms combine both cloud and edge-based features. 1. Arduino. 1. Arduino is an open-source platform that includes both hardware and software components. 2. Arduino boards are designed to make it easy for people to create interactive projects by providing a simple programming environment and a range of sensors and actuators. 3. Arduino boards are small and relatively inexpensive, making them ideal for hobbyists and students. 4. Arduino boards can be programmed using the Arduino IDE, which is available for Windows, Mac, and Linux. 1. Raspberry Pi. 1. Raspberry Pi is a single-board computer that runs on the Linux operating system. 2. Raspberry Pi is designed to be a low-cost solution for building IoT projects and includes built-in Wi-Fi and Bluetooth connectivity. 3. Raspberry Pi boards are more powerful than Arduino boards and can be used for a wider range of applications. 4. Raspberry Pi boards can be programmed using a variety of programming languages, including Python, C++, and Java. 1. Other IoT platforms. 1. BeagleBone is similar to Raspberry Pi in that it is a single-board computer, but it includes more built-in sensors and connectors. 2. ESP32 is a low-power Wi-Fi and Bluetooth-enabled microcontroller that is ideal for battery-powered IoT projects. 3. Particle is a cloud-based platform that provides tools for building, deploying, and managing IoT devices. 4. Other IoT platforms include Microsoft Azure IoT, AWS IoT, Google Cloud IoT, and IBM Watson IoT. 1. Data analytics for IoT. 1. IoT generates massive amounts of data, which can be difficult to manage and analyze. 2. Data analytics for IoT involves the use of various technologies and techniques to extract insights and value from IoT data. 3. There are 3 main types of analytics for IoT: descriptive, predictive, and prescriptive. 4. Descriptive analytics involves analyzing historical data to gain insights into past performance and trends. 5. Predictive analytics involves using statistical models and machine learning algorithms to predict future outcomes. 6. Prescriptive analytics involves using machine learning and optimization techniques to recommend actions that will improve future outcomes. 7. Data analytics for IoT requires a combination of hardware, software, and data science expertise. 1. Cloud for IoT. 1. Cloud computing provides a scalable and cost-effective solution for IoT deployments. 2. Cloud for IoT involves using cloud computing services to store and process data generated by IoT devices. 3. Cloud for IoT can provide benefits such as increased scalability, improved reliability, and reduced costs. 4. Cloud computing providers such as Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform offer a range of IoT-specific services, including IoT device management, data analytics, and machine learning. 1. Cloud storage models. 1. Cloud storage models for IoT involve using cloud storage services to store and manage data generated by IoT devices. 2. There are 3 main types of cloud storage models: object storage, block storage, and file storage. 3. Object storage is a scalable and cost-effective solution for storing large amounts of unstructured data, such as images and videos. 4. Block storage provides high-performance storage for structured data, such as databases. 5. File storage is a shared storage solution that provides access to files from multiple devices and locations. 1. Communication APIs. 1. Communication APIs for IoT involve using application programming interfaces, APIs, to enable communication between IoT devices and cloud services. 2. Communication APIs can be used for a range of purposes, including data transfer, device management, and security. 3. IoT communication APIs include protocols such as MQTT, COAP, and AMQP. 4. Cloud communication APIs include services such as AWS IoT, Microsoft Azure IoT Hub, and Google Cloud IoT Core. 1. Attacks in IoT systems. 1. IoT devices are vulnerable to a range of attacks due to their inherent lack of security features. 2. Attacks in IoT systems can be classified into 3 categories: confidentiality attacks, integrity attacks, and availability attacks. 3. Confidentiality attacks involve unauthorized access to sensitive data, such as personal information or business data. 4. Integrity attacks involve unauthorized modification or manipulation of data. 5. Availability attacks involve disrupting the availability of an IoT system, making it unavailable to users. 6. Common attacks in IoT systems include distributed denial of service, DDoS, attacks, malware and ransomware attacks, and man-in-the-middle, MITM, attacks. 7. IoT attacks can have serious consequences, including loss of data, financial losses, and even physical harm. 1. Vulnerability analysis in IoT. 1. Vulnerability analysis in IoT involves identifying potential vulnerabilities in IoT devices and systems and taking steps to mitigate them. 2. Vulnerability analysis includes both manual and automated techniques, such as penetration testing, vulnerability scanning, and code analysis. 3. Vulnerability analysis should be conducted throughout the entire lifecycle of an IoT device or system, from design and development to deployment and maintenance. 4. Best practices for vulnerability analysis in IoT include regularly updating software and firmware, using strong authentication and encryption, and implementing network segmentation to limit the impact of attacks. 1. Smart Home Case Study. 1. Smart homes use IoT technologies to automate and enhance various functions of a home, including lighting, heating, security, and entertainment. 2. One example of a smart home case study is the Amazon Echo, which uses voice commands to control various devices in the home, such as thermostats and smart lights. 3. Another example of a smart home case study is the Nest Learning Thermostat, which uses machine learning algorithms to learn the user's preferences and automatically adjust the temperature accordingly. 4. Smart home technologies can provide benefits such as improved energy efficiency, increased convenience, and enhanced security. 1. Smart Farming Case Study. 1. Smart farming uses IoT technologies to enhance various aspects of agricultural production, including crop monitoring, irrigation, and livestock management. 2. One example of a smart farming case study is the use of IoT sensors to monitor soil moisture levels and adjust irrigation accordingly, leading to improved crop yields and reduced water usage. 3. Another example of a smart farming case study is the use of IoT sensors to monitor the health and behavior of livestock, leading to improved animal welfare and increased productivity. 4. Smart farming technologies can provide benefits such as improved efficiency, increased sustainability, and reduced environmental impact.